In this last section of Chapter 2, we talk about quadratic models. That is, how can we apply what we know about quadratic functions to solve actual problems in the real world, which can be modeled with a quadratic function. So we'll do a couple of examples and then see what we've learned. Suppose a rock is thrown from the top of a cliff, and the rock's height can be modeled by the function h of x is negative 16x squared plus 96x plus 120. When does the rock hit its maximum height, and how high is the rock at this point? All right, they've missed out on a little bit of information here. I think let's just assume that x is going to be measured in time. All right, so this is saying after x many seconds, the height of the rock is whatever h of x is, negative 16x squared plus 96x plus 120. So we'll assume that h of x maybe is in feet. All right, now this is a quadratic function because it's an x squared function, and it's got a negative leading coefficient, which means it's an upside down parabola. It looks like this. We also know that the y-intercept is going to be 120 because h of 0 is equal to 120. So it hits the y-axis here at 120, and the rest of the graph will look something like this. Right? Technically, we can kind of disregard the stuff that happens before time equals 0 because we don't really know what was going on there. Right? We want to know when is does the rock hit its maximum height, and how high is the rock at this point? Which means we really want to know the maximum of this graph, right? The highest possible output of this graph. The x value will tell you the time at which it meets its height, and then the y value will tell you the height at that point. So essentially what we're looking for is the vertex. We want to find the vertex of the function h of x. If we can find the vertex of h of x, that will tell us the time that it reaches the max height and the height at that point. Now remember, to find the vertex, we need to use the formula negative b over 2a. That's your x value, and then h of negative 2 over ba. In other words, calculate negative b over 2a to find the x value, to find the time, and then plug that into the original function to find the height. Now, what are a and b in this case? Well, remember, a is the leading coefficient. That's the coefficient on the x squared term, so a would be negative 16. And b is the coefficient on the x term, so b would be 96. Using this formula, we get that negative b over 2a is going to be equal to negative 96 over 2 times negative 16. Okay, so you do this computation and you end up getting 3. So the x value that we're looking for is at time 3. So at time 3 seconds, the rock is going to hit its maximum height. To find the actual height itself, we need to plug that x value of 3 into the function h of x. So h of 3 is going to be negative 16 times 3 squared plus 96 times 3 plus 120. Right, so you might have to do a little bit of scratch work here or use a calculator, but you should get 264. So it's got a maximum height of 264 feet. Okay. In other words, the vertex is at 3,264. So it reaches a max height of 264 feet at time 3 seconds. Okay, so this would be an example of a projectile problem. Let's do a different kind of an application problem. This time we're going to say that a company determines that the revenue that they generate can be modeled with the function r of x equals negative 3x squared plus 56x, where x is the number of items sold. What's the maximum revenue that they can achieve, and how many items must they sell to achieve it? Well, again, if we try and think about what this graph looks like, it's quadratic and its leading coefficient is negative 3. So it's going to look like a parabola that's upside down. And it has a y-intercept of 0 because r of 0 is equal to 0. So it's going to look something like this. We want to know, when does it reach the greatest revenue? So once again, we're looking for the maximum output of this function. We're looking for the vertex of this parabola. So again, we want to find the vertex. we can find using the formula negative b over 2a, r of negative b over 2a, right? Because this is a revenue function, r of x. All right, now our a is the leading coefficient, that's negative 3. B is the coefficient on the x term, that's 56. And so negative b over 2a is going to give you negative 56 over 2 times negative 3. That's negative 56 over 6, which actually isn't going to be a nice number. It's going to be something kind of messy, like 9.3-ish. Okay, which means this parabola has a vertex at roughly 9.3. The problem is you can't really sell 9.3 items. The items are discrete things, so you can sell 9 of them or you can sell 10 of them, and we're not really sure which one will give you the max, right? But you can try and estimate it, or you can try to figure out exactly which one will give you the max by plugging 9 into the revenue function and plugging 10 into the revenue function and see which is going to give you a greater output. Right? Neither of these will be technically the vertex. The vertex is up here. But we know that directly on either side of those, you're going to have the largest possible output, right? Because you can't actually sell 9.3 items, but you could sell 9 or 10. So I'm going to plug each one of them into this function. Negative 3 times 9 squared plus 56 times 9. This is going to give me a revenue of $261. And if I sold 10 items, this would be negative 3 times 10 squared plus 56 times 10. This is going to be $260. This means that the maximum revenue you could have is $261 because it's the bigger of the two. So you need to sell 9 items to achieve a max revenue by selling 9 items with the revenue being $261. All right, one more example. A farmer wants to enclose a rectangular space for their farm with fencing. So he has 100 feet of fencing to use, and he plans to use a river as one of the boundaries. All right, let's try and draw a little picture here. Here's our river. That's going to be one of the boundaries. And the farmer's going to put in 100 feet of fencing here. And it's a rectangular fence, which means whatever this x value is, it's going to be the same on both sides, but this other value could be different. Right? Let's call that y. Now, we know that the area is going to be x times y, and that's what we're trying to maximize, except that's not really something that we know how to graph because it has 2 variables. Technically, though, y isn't going to be a variable, its own separate variable. Y is going to depend on x because we know that in total there's 100 feet of fencing. Right? We know that 100 is going to be equal to x plus y because he has 100 feet to use. That is 100 is equal to 2x plus y, which means we could rewrite this as 100 minus 2x is equal to y. So if I wanted to write this area function just in terms of x, I can replace this y value with this thing that it's equal to, 100 minus 2x. And now I can express this area function as x times 100 minus 2x. Or I can express it as 100x minus 2x squared. If I were to just distribute this, that's what I get. And rewriting this just so that I have the leading coefficient in front, I'd have negative 2x squared plus 100x is my area function. Now I want to maximize the area. So I want to know what should x be in order to maximize this area function. Well, just like before, this is a parabola. It's got a negative leading coefficient, so it's upside down. And we're trying to find where the area, the output, is maximized. So once again, we're looking for the parabola, or the vertex of the parabola. So I'm going to use the formula negative b over 2a. That's going to be negative 100 over 2 times negative 2, right? Because b is the coefficient on the x term and a is the coefficient on the x squared term. This is negative 100 over negative 4, which is 25. All right, what this means is that your area will be maximized when x is equal to 25, and we know that there's a total of 100 feet of fencing, so that means that this third side would have to be 50 feet long, and in that case the area would be 25 times 50. So that would be whatever that would be. Okay, 25 times 50, something. All right, and so this gives you your maximum area. I just want to point out quickly that in all three examples, we needed to find the vertex of the parabola. This is going to come up a lot in any kind of quadratic application problem. You're very often going to be looking for the vertex. So knowing that negative b over 2a formula is going to come in handy.